Alright folks, I wanted to show you how to graph a quadratic equation that's in vertex form. You'll see my equation is y equals -2 times the quantity of x minus 3 squared plus 6. And this is in vertex form. So a lot of the things that we do when we're going to graph this are pretty easy. The first thing I want to notice is I want to figure out whether this equation opens up or down so I can get a good idea of whether it goes like this on the paper or whether it's going to go like this on my graph. So in order to do that, as I told you, you look here at the value for a. And since a is negative in this particular equation, we know that this equation is going to open down. So we're going to have a quadratic that looks like this when it's all said and done. The next thing I want to figure out is I want to look at where the axis of symmetry is. And if you think of what vertex form tells us, y equals a times the quantity of x minus h squared plus k, the axis of symmetry is going to be at the h value. So in this particular equation, h is equal to 3. So the axis of symmetry is at x equals 3. Now this also is going to be the same value, the x value of the vertex. So I can start my vertex at the coordinate 3. If you think about it, the equation is going to start at the origin, right? The quadratic, the parent function of the quadratic starts at the origin. And then this tells me shifted to the right 3 units, And then this part tells me up 6. So I'm just going to go ahead and plot that point. Okay, and that's the vertex, 3, 6. So let's talk about the domain. Well, we look at this equation right here, and we don't any value. I'm not going to ever divide by 0. I'm not going to take the square root of a negative number. So there's really no restriction on the number that I can square, right? I can square any number. Pick any number you'd like. I can square it. I'm going to get another real number. So the domain, it goes from -infinity to +infinity. Now remember, I told you could write it like that, or you can use the symbol for all real numbers. Either would be acceptable here. The range, on the other hand, if we think about a quadratic equation, a quadratic equation has a highest or a lowest value for the range. So in this particular case, we have a highest y value because this thing opens down. We said it opens down. We said it looks like this. So that vertex right here is a maximum. So if I can look at it, if I think about it, this thing's going to go a little bit. It's going to go up and hit that vertex, and then it's going to go down again. So that is the highest y value I'm going to have of 6. So everything has to be lower than that. So my range starts at -infinity, goes to 6, includes the 6. If I wrote that as an inequality, it would be y less than or equal to +6. So I have a really good idea about what this quadratic looks like before I go any further than this. I know that it's going to have a maximum value here at 3, 6, and I know it's going to curve and open downward. But let's get a couple more details in place here. I'd like to figure out what the y-intercept is next. And if you remember from an algebraic standpoint, the y-intercept, in order to find a y-intercept, we take x and we make x equal to 0. And we plug that into our equation. So y equals -2 times 0 minus 3 squared plus 6. And if I simplify that, I'll do what's inside the parentheses first. I'll apply my exponent. I'll perform my multiplication. And finally, I'll combine my like terms. Do my addition. Following PEMDAS. So again, parentheses, exponents, multiplication, addition, to get my final answer of y equals 12. So my y-intercept is at 0, -12. That's actually going to show up on my graph, because if you see 1, 2, 3, 4, 5, 6, 7, I only go down to the -7 here. So my y-intercept is not going to show up on my graph, so I'm not going to plot that. Let's talk about the x-intercept. Where is the x-intercept going to happen? Well, again, the x-intercept is a little bit more work here. We're going to have to set y equal to 0, and we're going to solve this equation. Now if you think about what I'm doing to x and the order in which I do things to x, I took x, I subtracted 3, I squared it, I multiplied it by -2, and then I added 6. I need to undo all of those things. I need to undo them in the opposite order I did them in. So since adding 6 is the last thing I would do, it is the first thing I need to undo. So I'll subtract 6 from both sides. 0 minus 6 gets me -6. These 6's over here cancel out. I'm left with -2 times x minus 3 squared. Now, I told you that, so we undid this addition. Now we need to undo this multiplication. So we're going to get rid of the -2. And the way that we can get rid of the multiplication of -2 is to divide by -2. So these -2's will cancel out. -6 divided by -2 is 3. And on the other side, I have x minus 3, that quantity squared. So now it's time to undo the exponent. So how do I undo a square? Well, to undo a square, I'm going to take the square root of both sides. Now remember, this says what squared gives me 3. And if you think about that, there's actually two values that I could square to get 3. Now I know they're not nice numbers, but it could be the positive version of that number, and a negative times a negative will also give me a positive value. So this value could be plus or minus. It could be positive or negative, the square root of 3. I need to keep that in mind. This here, the radical and the square root cancel each other out. So I'm left with x minus 3 equals plus or minus the square root of 3. This plus or minus, that's really weird to work with. So I'm going to actually split this to do different problems. I'm going to make it x minus 3 equals the square root of 3, and x minus 3 equals negative the square root of 3. Now to solve for x, I simply add 3 to both sides. I can finally do that, get rid of what was inside of my parentheses. I'll do them both at the same time to sign just a little bit here. And I get 3 plus the square root of 3 and 3 minus the square root of 3. These are the exact values of the vertex. I'm sorry, of the x-intercepts. These are the exact values of x-intercepts. Now, this doesn't help me at all when I'm looking at graphing. So when I'm trying to graph this, I think it's really nice to look at the decimal equivalent of that. And even though the numbers are not nice, it will give me an idea of where my graph crosses the x-intercept or x-axis. So 4.732. Let me write these up here. So I have 3 plus the square root of 3, comma 0. And 3 minus the square root of 3, comma 0. So again, this 4.732, let's see, where is that on my graph? So 1, 2, 3, 4, not quite 5, but almost there, about 3/4 of the way. That's probably about the x-intercept. The other one, the decimal equivalent, was 1.2679. Okay, so 1 point around, let's see here, so 1 and around 1/4 of the way, probably around there somewhere. So now I have my two x-intercepts. I said my y-intercept is going to be way down here. I'm not going to be able to fit it on my graph. I have my vertex plotted. I think I'd really like to get a table of values going too to help me out with this. So one of the things I want to do is I want to put my vertex right here in the middle. And then because of symmetry, it's going to be easy to build up that table and build down that table. So here we go. So let's see. I'll plug in 4 into my equation. So let's see here. 4 minus 3 is 1. 1 squared is 1 times -2 is -2 plus 6 gives me 4. And because of symmetry, I know that this point is going to be exactly the same thing. Let me plug in 5 into my equation. 5 minus 3 is 2. 2 squared is 4. 4 times -2 is -8 plus 6 is -2. So again, because of symmetry, that this is going to be exactly the same. That now will give me a nice table of values to plot. I can plot these points. So if I plot these points, I should be able to come up with a pretty good idea of what my graph looks like. So I do that, and now I can just come in here, finish out graph. And that is how you quadratic in vertex form.